Hi everyone. Am I audible? Can someone respond?
At least I can hear. Let's check with others.
Raymond, thank you. Okay, that means that the system is working. Yeah. Uh, Good afternoon, ladies and gentlemen. Welcome to our webinar series. And today the webinar topic is the AI-driven DCI, designing and testing next generation multi-fiber and hollow core networks. I'm here with you, Rusafie, the Secretariat Advisor from Fiber Network Council, and my guest today, Mr. Raymond Lai. I'll give an intro to Raymond a bit later. Before that, just to give you a brief about the council. I think most of the people already knows FTTH Council. We have started as FTTH Council Asia Pacific back in 2005, and our mission is to promote full fiber based connectivity across the Asia Pacific region. And we basically want to advance the fiber optic technologies to drive economic growth, sustainability, and quality of life. So that's what we do. Very short intro. So before we start, just a bit of housekeeping notes to everyone that after Raymond's presentation, there will be 10 minutes assigned for the Q&A session. So we will try to discuss as many as points with Raymond's, definitely which will be asked by you guys. So you can just go to the Q&A part of the Microsoft Teams platform, and whatever you thing should be asked, you can make your question right, and we will try to cover as many as possible. So that's kind of it. So now coming to Raymond's bio. With over 20 years of experience in optical networking and test innovation, Raymond is now the APAC Technical Director at EXFO, helping operators, hyperscalers, and data center providers build AI-ready high-capacity networks across the region. He specializes in validating next-generation optical infrastructure, including 400G, 800G, and emerging 1.6 terabyte technologies, with expertise spanning high-speed Ethernet, OTN, DWDM, ROADM, fiber channel, 5G transport, and whatnot. So Raymond also contributes to industry best practices in automated testing, fiber characterization, and network assurance, enabling scalable, reliable, and high-performance digital infrastructure. So without further ado, I'd like to welcome Raymond for your presentation. So the floor is yours. Please welcome Raymond.
Thank you, Rusafie. Good afternoon, team, and good day wherever you are from. So just quick check, my audio and visual is good, Rusafie?
Yes, perfectly fine.
Okay, right. Okay. Right. So this is my agenda for today. We're going to target to bring you a little bit of virtual tour to what the hot topic of AI is all about. And then along the way, we like to share with you our involvement in learning the challenges through the practical field work that we have done. And hopefully towards the end, you will also pick up some emerging technology like hollow core fiber. So this is basically my rundown. So now a quick one about my company. If your first time, EXFO, I always associate to expertise in fiber optic, and the company is founded in Canada back in 1985. From day one, the company has been focused on fiber optic, where no one else is even bothering, because at time people just happy with whatever they had, copper at the time. And over the years, fiber become a mainstream, especially AI, it is even more so. So with that, I would like to share with you in the journey towards AI era, what we actually have learned, and it will be a good place to share at the same time to learn from the audience as well. Feel free to put your question in the chat if you have any. Now, the first part, I would like to bring you a quick journey to where we have gone through from before 2010, where the networking is still divided into the old school method of local area network and then wide area network, right? So particularly in that structure of the old connectivity, server are critical, but they are not everything because there wasn't any computing power. It just served single purpose. Because of that, the architecture at that time was really running on 3-tier with lower speed. You can see here 1G, 10G, 100G, and then more and more so, this architecture become out of date when we are welcoming the era of AI. And what is the changes you probably can observe in the AI era is keeping it more lenient from 3-tiered to 2-tiered. That already saving the latency. And why do we need latency, by the way, in the AI era? Because it's about computing power, and so it's the self-learning among the GPUs to become intelligent and to serve whatever purpose you want it to be, right? And to do that, it become from serial connections to become a parallel connection. And in the name of oversubscription, it used to be 1:3 before 2010, now become 1:1. So essentially, one server is connecting to all the spine switches accordingly, and it is high density switches. At this point, maybe you're still not clear where I'm trying to bring you to, but stay with me because I'll bring you a virtual tour shortly after this, behind the switches, behind the connectivity, which now is all MPO. And then behind each server, it is really high-speed connections like 400 gig and beyond 400 gig. You probably have heard 800 already in the newer generation of NVIDIA platform. And the next is, of course, 1.6, right? Now, in the evolution itself, 3-tiered, 2-tiered, increased speed, and also better oversubscription management. We see that the multiple technology are in play right now, and you can see that on the right side, we see a lot of single mode applications that is spanning from lower fiber density, meaning that duplex fiber, to become parallel optics in the number of 8 to 12, and then on the spine and leaf connectivity, we even see higher number of fiber because in the going forward as well, this amount of fiber is so big that is even harder for the installation within the data center to easily run through. And shortly, I will bring you to the virtual tour and hence introductions of BSFF, very small form factor and multiple fiber technology to condense, such as a multi-core fiber, in order to condense and reduce the weight so that the AI data center won't be so congested. At the same time, leaving some more space for cooling, which is so critical in the AI era in the GPU cluster. Now, with that said, I would want to bring you a little bit journey into how do we put all these AI data center together in real life. Let's take a look. Let's say I define this, I call this a rack. Multiple of this rack, which can be putting the server, switches, and the GPU is going to fill up the whole data hall. And with that said, we want to, for example, connect one GPU to another. So 4 fiber are commonly used. You see single mode fiber, you see multi-mode fiber, and then we also see some connectivity to the switch using AOC, DAC type cable. When everything is racking up, then finally it is in full operation. If I put it in the perspective of the real life, let's take a look here. This is a virtual tour that everyone is talking about NVIDIA GPU, right? I really want to show you behind that, advanced, massive, parallel learning and high speed. You can see that these are all possible, and it is really being enabled by means of high density number of fiber. And there you go. In this example is 400G SR4. 8 fiber multi-mode is there. This is already 1 year ago when we prepared this, but fast forward today, you can see that even higher fiber count are there, single mode are there, and let's take a look like this, what kind of contribution of fibers behind this GPU. So this is a computer data hall taken from one real customer, put it anonymity, but let's say this is 100,000 of GPU with equivalent to 1,500 plus rack. And now the networking is mission critical, as a cluster is working as a giant computer, learning from each other real time, parallelly, and so on, serving millions of subscribers. But in that extreme dense network, they are hiding millions of fiber links. And being Fiber Network Council, we are particularly interested in fiber link, right? Let's take a look. Sorry, the animation might be slow on the side here, but this is an example of a 64 port switch. Okay, every of the port is 800 gig already capable. And later we're going to do the mathematics to calculate how many fibers are there and what has it got to do with us being in this FNCAP on the mission to ensure that we always have first time right and ensure all fibers installed can serve the purpose and deliver their capacity unlimited. So this is a zoom in view of the trunk, and every trunk, imagine, is 432 fiber a year ago, and you can imagine now probably if not doubling, there will be a factor of 1.5 or more. And we are looking at the snapshot, just hundreds of trunks in this picture only. And if I zoom out again, allow me to go to this data hall and check out another perspective of one of these switches, right? Which one of the switches itself can be 512 fibers, all right? And this 512 fibers is in the form factor of MPO connection. If I put all this, calculate all these switch together, 13 number of them, 6,000 plus, all right? So you can imagine massive number of fiber connectivity, and hence it is good for us to just do a small conclusion of what has changed in this massive AI pod or AI cluster. Okay, so we can do a quick summary of what has changed. Number one is really the transceiver. Transceiver here has shown that in the past we only have TX and RX, two direction. Now, because we are talking about 400 gig, there will be 4 TX and 4 RX, so 8 fiber there. We're talking about 800 gig, potentially 8 TX and 8 RX. So that makes the number continue to doubling up. And there's also a form factor that has 2 MPO connector sitting on the transceiver as a new trend. The other trend is because there are so massive number of fiber everywhere. So then some formula to downsize the fiber optic, be it a connector and the fibers are critical. On the connectors first, you can see LC duplex has a new flavor we call it VSFF, very small form factor, promoted by Senko here, MDC being promoted by US Connect. And on the other side, NTT and also this MPO selection is there. And then we also see that US Connect has come out in another favor of MTP, same form factor of MTP they call. On the right side is a very small form factor, and just to give you a perspective, when we say very small, how small? 2.7 times denser. How about that? How about this? Oops. This is actually two times smaller on the top of the duplex configurations. Then on the right side, beside connector, fiber need to be condensed as well. We have heard multi-core fiber option. We also see that there will be more cores, which is multi-core. There will be even smaller diameter for the fiber and different ribbonized technique to condense and reduce the coating size. All in all, we need a lot of proper management to put more fiber to serve the ever-growing AI, which, like, if you pay attention to the GTC, they are even condensed smaller and smaller. And the new trend, actually, the next step is CPO and so on. So now, with that said, I would like to share to you, like, being involved for the past few years with the hyperscaler from the US globally to Asia Pac, many activities happening right now from Japan, Korea, and Singapore, especially JB, Malaysia, Thailand. I'm here currently. There's so much of things is happening. Data center in Malaysia, Vietnam, so on and so forth, Philippines. So I would like to share to you, like, this is really some key takeaway interest or area that you can take away today. Time, referencing, polarity of the MPO connectors, and diversity of the connectors. So these are the 4 areas that I would like to bring attention to. If you ever being participate, you definitely don't want to cut the corner, but you want to cut short your first time right, to get everything up and running, because later you see. Okay, so let's start with the time. This slide is just wanted to show you outside there's a lot of hot money. Okay, so I just want to give you a perspective that why testing is critical, because one of these GPU, you can see that is a huge capex. Can you imagine that typical one rack is around 1 to 3 million, depending on your configuration? Huge capex investment, and in order to monetize this investment, what we probably wanted to ensure in the process of from zero to everything set up is, to ensure the fiber infrastructure is 100% functional. It's super crucial. So now this relates to if we don't get it right first time, this is the losses you're going to associate. If GPU is not performing up to the expectation, and then troubleshooting need to find which connections need to be rectified and correct, is really a pain. And with that said, we associate to the market. Number one thing probably you look at is, hey, you probably are looking into some tester category, and in the tester, you have 3 category in the market. One that can offer 1 second, the other one 4 seconds, the other 6 seconds. What does it mean to associate to the high fiber count you have seen earlier on? It simply means that if you need 1 week to complete your job with tester A that runs 1 second, compared to tester B that is 4 seconds, you need 4 weeks to complete it. If it is 6 seconds in operation time, you need 6 weeks to complete. This is the perspective, and multiplied by months. This is really why we hear people think that, hey, can I cut a corner, skip the testing and go roll out straight away? You can, but when things are happening, how can you dig in the pulse of fiber to undo the damages, which can be essentially first time right? So testing is essential, and it has to be done correctly. How the correct process is about referencing, referencing. So let's take a look about referencing, what you can learn from that lessons. A little bit step back on the industrial best practices. Referencing can come with like 1, 2, 3 chord. Of course, the recommended one is a 1 chord, being the most accurate, and the other 2 method is also accepted by IEC. But if you really look carefully, the 2 chord method only contribute to 1 connections and also 1 fiber. Then the 3 chord method essentially is giving you just a fiber measurements, nothing to do with connector as well. And this really is not satisfactory. And most hyperscaler who are AI GPU cluster, enabler, they wanted to use the 1 chord to start with. Okay, so 1 chord is our step 1. Step 2. In order to do the 1 chord referencing, we need to look at our tools, right? So what are the tools available out there? For example, the thumb rule, first of all, to share with. So example, these are the tools that's available in the market. And you know that MPO has got female and male type. Assuming that your equipment the tools that you wanted to validate all these connections, they are mail type start with. And do you know what is the thumb rule between the relationship of tools and also your FUT, the fiber links? Actually, the thumb rule is quite straightforward. In order to measure for example, mail connection, your equipment need to be mail. So probably this is the one key takeaway for you to learn. And then if your DUT or FUT is fiber under test, by the way, is happen to be a female, you want to ensure that your power meter or the receiver side would be the female type as well. So this is the thumb rule. So I have A condition and B condition. If you are not, then you probably have to use 2-chord and 3-chord. That is undesirable. And also in the AI data center, you can see that beside having the connectivity to using the MPO, there are still abundant of duplex connectivity here. So it's not like everything is only MPO, because server, they probably are just duplex connections. So before, we see that 400G and below, they are very much MPO base 8, sometimes base 12. But today with the 800G, the new advancement on the technology like GPU, you see that 16 is very common. There are different flavor of MPO 16 or MMC 16 are there as well. So duplex are moving to more uniboot in order to save space. Yeah. So these are the common things. So your challenge here is that while you are doing the link certification, we call it tier 1 normally, you need to manage MPO. You need to manage duplex as well. So this is the challenge. Normally, you need to have a 2 separate tools to do this job. Now, with that said, the solution with the pain point that we just shared, being pin, unpin to achieve 1 chord and also duplex are there. It is important to see that when you are doing shopping, right? You want to find tools that can help you ensure that the tool is fully compatible. For example, this is one example. You can go switching between the duplex adapters and also the MPO adapter. MPO can be pin and unpin for that matters. How does it work? So you can see even beside the LC, the VSFF, very small form factor, being a new trend in AI, are considered as well. So changing the adapter accordingly just make life so easier and your investment to the minimum while not sacrificing what is essential in the AI network. That means the health conditions on the fiber links. And talking about the 1 chord reference, we talk about chord, but there's a catch for using the chord. Yeah? There's a lifespan of using the chord. If you really look at the different manufacturer, they give a different lifespan of it. For example, 200 times mating or 500 times mating. These are the 2 numbers I commonly hear in the market. But essentially, it is like how good you are taking care of your test reference chord before it gets wear and tear. It has to be totally replaced. So at least using, the market, there are 2 flavor one out there. One is using the native of the shelf cable as a reference chord, meaning that if it is MPO 16, then you use off-the-shelf MPO 16. The other category you probably can see in the market as well is a Y cable. It's not that they are not good, but it's not that simple anymore because you need to connect a Y cable, and in order to achieve the 1 chord, sometimes it can be difficult, and being a proprietary cable as well, that will be a cost to come with that. So then, watch out for these hidden costs as you are shopping to ensure you have the right tool to do the job. How about the other one on polarity? So what is polarity? Yeah? So polarity actually is a challenge. For example, if you don't, if you overlook this matter, sometimes the mismatch on the fiber, for example, this is supposed to be AB, that output is supposed to be BA because TX connect to RX is not properly done, then your connectivity it will fail completely. Cannot do any communications of the advanced high-speed equipment. That is a big problem. You know what? There are how many type of polarity out there, but the most common one, luckily, normally people use either A or B, A being straight, B reverse. And the challenge here is, even though you call it A, B, C, or U, they look the same from outside. So this is a big challenge. So then how do we then know that is a big problem? Because if you refer back to the virtual tour I brought you earlier on, massive connectivity, and it's just so pain, eventually, if you discover that your polarity is wrong at the end of your installation. So a quick solution review to show that nowadays testing is not just focused on insertion loss and also the length. Polarity is also one key thing. This is just a snapshot of how you can identify what's wrong and where's wrong. Of course, the last one is the connectors diversity, I would say, and take a look here. So having to support the existing 8 and 12, now we see 16, 24 coming up. We see VSFF, we see different vendor like Senko, YesConnect have their own flavor. So this is a small video to show you that, if you can find a tool that can do exactly everything, that will be ideal to ensure you still keeping the one chord accuracy, but also reducing your capex simply by, changing the adapter to suit the different diversity of the connector out there. So these are the 4 main challenges that we have seen that can be easily overcome. And right now, you already got a shortcut. Just a small commercial. If you're looking into the tool out there, of course, my company served that purpose to do this P24 to do up to 24, can be 16, 8 or 12 duplex with a different adapter, 1 second test time. That pattern pending click-out adapter is really what we pride of, being first innovation of such in the market. Last week I was in Interop, Japan, and we got the best show of awards, so pleasure to share with you. And between the data center, let's talk about DCI, right? So now this is a data center we started with. And if I condense the data center in one block, multiple campus of this, we call this a DCI connectivity. And that DCI connectivity not only can be just campus, but metro. So it's connectivity between 2 or more data center, usually high capacity, low latency are expected. And you know what? Extension to what we discussed. All right, we talk about multiple measurement in order to ensure all the connections are in great health condition before they go live. So when on the DCI, we wanted to do a little bit more. For example, there are splice outdoor to go from one building to another, typically less than 80 kilometers without any amplifier. We want to do something. We want to characterize a splice. We want to know a little bit more beside the one direction of insertion loss, length, and polarity. We want to know their optical return loss to know the condition on the connectors. We want to also know that how does it goes when we are dealing with splice in the terms of bidirectional. It's a measurement technology that ensure we get a positive value on the loss accordingly. Last but not least, if any of this condition is broken, let's say splice is really bad, where is it? Where are they located from the 80 kilometer long range of DCI fiber? And this is where we have the latest OLTS technology in order to assist us not only to do the tier 1 certification, but tier 2 as well. The way how it is done is with that high density number of fiber optic. For example, in this example, I just put the tools on 2 sides. And the tools will serve as first primary function, being the OLTS. They'll be able to measure up to 24. When you selected number 6, you know which fiber is good and bad. Secondary and the main function of it as well is fault detection. I know pick green for good, red for no good. And if it's no good, location of it and how bad is the value and so on. So this is really the extension to the inside data center to the DCI trend. And on top of that, in the market also, everyone is having a major pain point of doing a referencing can be a 4 connection thing, like 1, 2, 3, 4. So when something goes wrong in the referencing, how are you going to commonly troubleshoot and find out which connections is? And this is the biggest pain point that you have to do 1, 2, 3, 4, open it up, clean it, put it back, test, fail again, open it up, and then continuously do this repetitively, half an hour without having to know exactly what you're doing. It's a very common pain point. So in the market, you can see that if you can find someone who actually has the capability to do smart referencing, pinpoint to the exact location of the connection that is weak, and either you do a cleaning to resolve it or not replace the reference code or substitute code, we call it SC, that will do the job. Straightforward, fast, and eliminating the pain point out there. So this is really the way to go with that FTB Lite, a little bit larger unit, larger screen, because it serves the as the OTDR, bidirectional OTDR as well. Beside that. Now DCI. So one thing interesting about new trend on the DCI is being hollow core fiber, I would say. So well, guys, just quick pause in case you have any question. Keep them coming on the chat, yeah. So I'll be looking at it right after this. So now on the DCI, we talk about metro and edge already. So and if you look at the new trend in the hollow core fiber, it is really still the optical fiber, but instead of traveling through the glass, as you see on the right side here, the new one actually is traveling through the gas. So what is what the let's say characteristic comparison of the two? Let's take a look. So core material, of course, it go from either gas or special type of gas or just air versus a solid glass. And the gas actually has to be a low pressure so that when it is exposed, then you don't see that the outside gas would rush into the hollow core. So that's one way to protect the hollow core for a long time. The other one is really the performance, because now light is traveling through the glass, something, so the resistance is higher. There's no resistance here. That means our performance on latency are improved like 30 to 40%. In real life, this translates into measurable attenuation, 0.04 from one of the vendor that we actually have done the testing, also in Introp, Japan last 2 weeks ago. And then here, the glass fiber ultra low loss, super good, a little bit expensive, but it does a 0.16 dB per kilometer, already so good out there. And then we can see also power handling, because through the air, you can see that heat is not a problem as compared to the glass. So it then can handle more higher power transmission per se. One thing is still remaining a challenge, that even though hollow core fiber looks on paper, everything is better than glass, but ITU-T standard already has the definition for glass, and they are still work in the background to see it being defined. But having said that, because of the benefit that I just mentioned here, people are rushing to deploy the early phase of hollow core already. So it is still in the infancy stage, but real life deployment has been seen everywhere. If not in the field, there will be some operator who roll it out live, financial company who roll it out live to give it a try. For them to have the benefit of lower latency, even for AI pod as well, the learning between the GPU can be as committed as best using this. Beside communication, AI, DCI, for using the hollow core fiber, do you know that anything related to high power laser, this is another use cases. And the next cases is sensing. Do you also know that with the enhanced environment sensitivity, hollow core fiber is used to detect any environmental changes such as temperature and pressure. So this fiber do not need standardization, because to the user, so long that it met the commercial purpose, it helped me to protect my let's say the asset using the sensing system, it is already a justification to go ahead. So industry is really rushing quite rapidly into hollow core fiber already. So testing, all right, we for me, our expertise is testing. I like to correlate to the testing area. The top 4 area that we want to share to you, observing from our perspective, is really the technology. There are already like many generations. This is not new technology. 20 plus years. It used to be a super high loss, more than what hundreds of dB loss to today 0.04, a mega achievement. But we see that one thing for sure, the NANF NAND is really used as the one of the ultimate choice that has been quite successfully uh, commercial deployment out there. And hollow fiber is filled with inert gas at low pressure, as I mentioned. And of course, the challenges is hollow fiber is a fiber that's different than the glass fiber. Today, deployment are all massively glass fiber. We call it SMF, single mode fiber. How do we then interface the two? Right, the interface of the two create a new issue called reflectant that was not there before. So this is another area that we see. And last but not least, attenuation. We discussed this. So we show you one of the many success that we have got on the hollow core fiber live test. And this, if you running a hollow core test, OTDR probably is the best bet today. Of course, there are many other methods, for example, like source parameter at the other end. And later I'll share to you what are the other options. But the challenge, if you are running a test starting from connector with the first section of single mode fiber, you get a good result here. As you are going through the hollow core fiber, you see that significant drop due to the refraction is quite near to nothing in the hollow core fiber. And with that, I would say if you have a hollow core splicing, you'll be hidden inside what we call as an effect called gas filling event. Essentially, gas filling event simply means that, hey, you have the OTDR trace that tell you the status of the fiber condition with that GFE combined. That means you have no idea what is what. And in this case, having a smart algorithm like what we have developed, we are able to identify the GFE, remove them, and produce what we call as original baseline with all the clear reflectant accordingly. So from here, unsure, because sometimes the peak can be just hidden, versus now you clearly see the peak, the reflectance of each and every of the event. That thanks to the know-how on the fiber measurement techniques, smart reflectometer that we are doing. Beside having a different way to do the OTDR measurements for installation and so on. Another one is really looking at the dispersion. So what's so special about dispersion is actually based on the standard ITU-T G.650.3. We see that beside OTDR, CD and PMD is there. And for EXFO, we recommend dispersion testing to be anywhere like 10 kilometer or any rate like 10 gigabits. Relate back to the data center speed that we have there, easily 400, 800. When it actually goes through the DCI, and with this DCI distance being more than 10 kilometer, certainly dispersion become critical. And dispersion can be done effortlessly, single-ended. So for example, you have a whatever mesh topology, putting a single dispersion tool, you'll be able to collect two information, CD coefficient, PMD coefficient, right here. So with that said, this is a standard, but more importantly is that now we're talking about latency world, right? So one of the side fringe benefit we get out of the dispersion measurement nowadays is identifying on the latency. Because let's say in the CD, we are using the time of flight technology, meaning the CD is able to measure across the wavelength. So this is a spectrum of wavelength. And with that RGD value, we actually can associate every wavelength to know their respective latency, because many of the DCI, they are coherent related, tunable laser related, DWDM related. So they work across spectrum. So and in the spectrum, there'll be multiple channel like C-band and L-band, right? So having able to got visibility that if one of the channel is low latency, haha, red flag and action to be taken. And it is super useful, especially DCI is concerned, bank, MNO operator, where they associate delay and synchronization methods in their business. So last but not least, coming to the end already, I would like to say, beside OTDR, there's a bunch of others fiber characterization tool out there, including how do I check and detect the intrusions of humidity or gas or water or anything into the hollow core fiber because it is hollow, right? Then spectra measurement is very common in that case, and this is just for your quick reference. Interop again, our live test proof testimonial to go with YOFC, one of the hollow core fiber supplier on the show. This is there. So all in all, if I wanted to recap, I have brought you through the AI pod era where beside you can see that the high fiber count in the deployment, MPO are introduced, and then transceiver are there as well. And then on the top part, you can see that here is a server racks and leaf. This is a leaf and spine, even higher fiber density. From MPO, it becomes VSFF. And then in terms of the speed, we see 800, 400 to become the 800 there. Today, due to the time, I'm only managed to show you the Tier 1 certification story, but I have a lot more interesting one on the data side. And hopefully, I'm counting on the next webinar to share with you a little bit more insight on the network side. If you are interested, please let us know on the chat so that we will take your feedback as our motivation to do another great one for you. Multi-core fiber there. Now, on the DCI side, we see that beside the network, we also see LC simplex, duplex, WDM mux, and so on. You know, just to recap, the challenges can be easily dealt with if we have the first time right mentality, not only scoping, not only the network testing, the optical spectrum analyzer, and so it's a Tier 1 and Tier 2 combined solution, and fiber monitoring as well, 24/7 monitoring the DCI fiber, and of course, hollow core fiber is a new addition that we just covered today. Okay, so with that recap, I would say I will come to a Q&A session. So I'm just looping back in Rusafie to join me for the Q&A session. I only have one screen, so let me just go to the chat if anything for me.
Sure. Great session, Raymond. Thanks a lot. So it was really very insightful and timely topic you have selected. So to the audience again, please feel free to write your questions in the Q&A section. If you have any queries, questions, and we will try to answer those questions. So let us know if you have any queries, questions. And but we can start from some of my preset questions, like some of the questions, topics actually interest me as well. So number one is that, Raymond, why is polarity validation becoming more important than simple insertion loss testing? So this polarity validation, if you can add something on this.
Certainly. Well, I think the easier way to associate is that connectivity between server and equipment, they have polarity, TX to RX. If somehow polarity is reversed, the worst case is that the traffic cannot go through. Right. So this is the thing. And polarity is important because as we are talking about the connectivity like MPO, we have higher and higher fiber count, 8 numbers, 12 number, 16 number, and having a different polarity also happening between MPO to LC cassette, like MPO one side and multiple LC there, that on the other side. any base 8, base 12, base 16 architecture will be affected badly. Hence, when we are doing the kind of first time checking on the fiber infrastructure, that should be one of our priority beside the traditional just insertion loss measurement.
Okay, that's great. And the next question I have on that hollow core fiber, it's the hot topic everywhere now. So in terms of that thing, hollow core fiber, definitely it's the promising thing for low latency DCI. So what are the real testing challenges before wide deployment of this uh, spatial type of cable?
Oh, very good question. It is an interesting one because there wasn't any reference in the past in relation to how do I characterize a hollow core fiber. From the fundamental part of the hollow core fiber itself, the cost of hollow core fiber is not cheap. Once it is deployed, if it is not really well taken care of, it would defeat the purpose of the investment in the first place. And why do I say so? Like hollow core fiber, today we are still interconnecting to the single mode fiber, glass fiber, that allow us to go from our current network asset, through the hollow core, low latency to the other side of the building, or the other side of the destination. So in that interchanging, for example, we commonly see that, hey, there's this newly introduced single mode fiber to hollow core fiber interface. And reflectors are pretty easily disturbing the high-speed transmission as well. And as I shared earlier in my slide, it is important to have the technology know-how, for example, to split the gas fuel event from the OTDR traces to make it efficient and to have it clear visibility. And this is only one part of it, right? Because this is where we ensure the hollow core fiber will work after installation. But the next challenge here is that how is the performance like? If I'm DCI and banking industry, finance, I'm more sensitive to latency. How do I ensure the latency are taken care of? So another aspect is beyond just OTDR, we really need to look into also inspection, and so it's a dispersion that is able to give us a more holistic event on the bigger investment. I would say, if not a few times, at least 10x or more investment compared to traditional glass fiber. Until the price come down to commodity price point, I would say that learning on dealing with hollow core fiber become, I'll say, a new challenge. But now the challenge are being managed already properly, at least from our company perspective.
Okay. Yeah, that's really great. So everywhere I go now, it's only hollow core, multi-core fiber. So that's pretty timely thing. So okay, so the last question I have is that since 800G is already here, so long haul DCI is also moving from 400G to 800G. So are the traditional acceptance tests still sufficient, or what do you think?
Mm-hmm. Well, if the audience can be participative, I would like to ask them what they think, because everyone come from a different background, everyone come from a different belief in the certifications. For me, basic tier one testing, for example, insertion loss and length are no longer sufficient, especially to deal with a DCI for higher speed. So we are looking at beyond the current tier 1 certification, we have to add in the element of bidirectional. We have to add in the element of ORL into it. And we also have to add in the perspective of tier 2 certification on top tier 1. Not only that, while I go back to my earlier point of dispersion, CD and PMD, especially CD time of flight, will be able to give visibility for all wavelength range to know the latency, if it is really a truly claimed low latency measurable over that DCI long haul fiber. So yeah, I believe that more information like this should be shared so that the awareness would benefit everyone to ensure that, hey, eventually your network is not just 800, 1.6 is coming, 3.2 are around the corner as well. So make sure that the AI is, very fast, rapid, right? And then the speed is doubling up, and our methodology is the same. So it's a mark for everyone.
Exactly. That's really nice discussion with you, but I think the time is limited. Otherwise, and also our audience pool is a bit shy to talk, I think, ask questions. So, but anytime we you can catch up with Raymond if you need any kind of assistance or any queries, even offline. You can uh, reach out to us. This is our email. If you have any queries, if you need any contact of Raymond, so please reach out to us, and we'll be more than happy to assist you in this regard. So, and just to close today's session with two of our upcoming conferences. The first one is the Pacific Fiber Conference 2026. It's happening next month in a beautiful uh, location, Fiji. So which will be hosted by TFL Telecom Fiji and supported by PETA, and it is organized by our Fiber Network Council. And the theme is very timely as well, the Pacific Connected Foundations for the AI Era. So you can get all the information in our website. The registration is going to be started from Monday. So please visit our website on this. And this is our annual conference, which is the Fiber Connect APAC conference, the biggest gathering in the fiber industry in Asia Pacific. This year's theme is Light the AI Revolution. Again, the AI, next gen fiber connectivity, and it will be held between 14 and 15 October at JW Marriott Kuala Lumpur. So we have already started communicating this conference. We are piling up speakers, interesting topics. So please engage with us, and feel free to give us any kind of feedback, and visit our website and our social handles for more updates. So for today, this is all from my side. I think I'd like to specially thank Mr. Raymond Lai for being with us as a speaker for today's webinar with a very timely topic, which the entire telco DC industry is talking about. I think I'd like to also thank EXFO for being the host of this webinar. So hope to catch you again very soon. If you have any queries, questions, feel free to ask us. And this recording will be available to you through our YouTube channel as well as over to email. So yeah, that's all from us. Thanks a lot, everyone. Take care. Bye.